We're going to go over the final review for Fall Semester PreCalculus today. So in this review, we've got 18 problems to go over. Let's begin. For 1 through 4, we are evaluating some functions. This is basically just asking you, do you know how to use your calculator? So f of x equals 5.4 to the x for x equals 3. This is saying plug into your calculator 5.4 to the power of 3. So this is 157.464. Okay, next, evaluate the function f of x equals e to the x for x equals 6. So to get e to the x, we see here in blue, we hit second, and then instead of the natural log, we will get e to the power of x. We're going to plug in 6 for x. This is 403.43. Number 3, evaluate the function f of x equals log base 10 of x for x equals 44. All right, in your calculator, it assumes that if you hit the log button here, that you are in common log, you're in base 10. So you don't actually have to plug in this 10 anywhere. You just hit log and then 44. And then enter. 1.643. And number 4, evaluate the function f of x equals the natural log of x. So the other logarithm that our calculator does is log base e, which is the natural log. So I put in natural log 6.4 for x. And this is 1.856. Okay, number 5 and 6. For problems 5 and 6, write the logarithmic equation in exponential form. And I've got a hint here. Log base 5 of 25 equals 2 can be rewritten as 5 to the second power equals 25. Now, an easy way to remember this is the following saying, the base of your logarithm is the base of your exponent. So if this is log base 5, then when I go to change this to an exponent, something to some other power, this will be 5 to some power. Then left to right, right to left. So the equal sign here, 25 is on the left of the equal sign. It will now appear on the right side of the equal sign. And then 2 is on the right side of this equal sign as it started out. Bring it over to the left, and that is the exponent. 5 to the second power equals 25. So when I look at this logarithm, log base 3 of 2,187 equals 7. The base of my logarithm is the base of my exponent. So 3 to what power? Left to right, right to left. 3 to the 7th power is equal to 2,187. And I can do the same thing for natural logs as well. Now, natural logs, this is just shorthand for saying log base e. So this is the same as log base e of 27.11 is equal to 3.3. Now, having written it like this, I can say the base of my logarithm is the base of my exponent. So e to the power of left to right, right to left. E to the power of 3.3 is equal to 27.11. For 7 and 8, I'm just going to go the other way. I'm going to start with something with an exponent here, and I'm going to change it to a logarithm. Now, what I had said before still applies here. The base of my logarithm is the base of my exponent. So if the exponent is 4 to the power of 4, okay, base is 4, then this will be log base 4. Log base 4 of what? Left to right, right to left. Log base 4 of 256 is equal to this 4. And the same here. The base of my logarithm is the base of my exponent. This is e to the power of 4.2. So I could say log base e, or just natural log. Left to right, right to left. The natural log of 66.686 is equal to 4.2. Now, as I mentioned, the calculator can only handle log base 10, that's the common log, or the natural log, that's log base e. So when I come across a problem such as number 9 and 10 here, evaluate the logarithm using the change of base formula. This is log base 4. I can't put this into my calculator as it is, but I do know that for change of base, I've got a formula that says the log base a of b is equal to, and then I can either use log base 10 or I can use natural log. Here, I'll just use log base 10. This is equal to log base 10 of b over log base 10 of a. So using my change of base formula, whatever I'm starting with that I can't just put into my calculator, I can just put in log base 10 of whatever I'm taking the logarithm of before over log base 10 of my old base. So this is going to be the same. Okay, so log base 4 of 22 is going to be the same as log base 10 of 22 over log base 10 of my old base is 4. So let's plug that into the calculator. Log 22 divided by log 4. And this tells me that this is 2.2297. So log base 4 of 22 is 2.2297. Number 10, log base 8 of 14. I can't do log base 8 in my calculator, so I say log base 8 of 14. This is the same as log base 10 of 14 over log base 10 of my old base is 8. Now I can go to my calculator and go log 14 over log 8. This is 1.2691. And that covers the first page. Let's move on to the second page. Okay, so for 11 and 12, I'm going to be doing some solving. For 11, I've got my x is stuck inside of this exponent here. And for number 12, my x is stuck inside of this logarithm. So these are going to be similar methods, slightly different. For 11, if x is stuck inside of an exponent, then you have to take the logarithm of both sides. But your base is going to be the same as the base of this exponent. So the base of this exponent is 7. What I want to do is I want to take log base 7 of the left side, 7 to the x over 3, is equal to log base 7 of 25.616. And I do this because of my exponent and logarithm rules that say if I've got log base 7 of 7 to the x over 3, whatever this base is, if this base matches the base of this exponent, these two undo each other, leaving just x over 3. So this will be x over 3 is equal to log base 7 of 25.616. But if I'm solving for x, then I can't do this part in my calculator. I'm going to have to do a change of base formula just like I did for the last two problems. So I'm going to change this and say that this is the same as log base 10 of 25.616 over log base 10 of my old base 7. Okay, let's first find out what that is. X over 3 is equal to log of 25.616 divided by log 7. Okay, so this is 1.6 repeating. Now, to solve for x, I'm going to multiply both sides by 3. So I'll get x is equal to, just multiply this by 3, 5.0000, well, that's close enough to 5. We'll say x is 5. Now compare this to number 12. In number 12, x is stuck inside of a logarithm. So what we need to do is exponentiate both sides. But before we get to that, we have to get this logarithm by itself. Now 11, this exponent was already isolated. But in 12, this logarithm has a 7 here. It's being multiplied by 5. So we have to get rid of some of these things first. Let's subtract 7 from both sides. On the left side, this will leave 5 times the natural log of 3x is equal to, on the right side, 15.959. We're subtracting 7, 8.959. Now let's divide both sides by 5. The natural log of 3x is equal to, divide this by 5, 1.7918. Okay, so now what I need to do is exponentiate both sides. What that means is once I have my logarithm isolated, I go, what is the base of this logarithm? Well, this is the natural log, so this is base e. What I'm going to do is say e to the left side is equal to e to the right side. And similar to number 11, if I've got logarithm, okay, and the base of that matches the base of this exponent, here this is e, and then the natural log is log base e. These two undo each other, leaving just the 3x is equal to e to the 1.7918, and then I'm going to divide both sides by 3. This will give me x is equal to, we can put this in the calculator, e to the 1.7918, and we're going to divide that by 3. What is this? 2.0000, close enough to 2. We will say x equals 2. All right, next, 13 and 14. These say evaluate exactly the 6 trigonometric functions of the real number t. So for 13, I've got t equals 5 pi over 6. I want to find the sine, cosine, tangent, cosecant, secant, and cotangent of this. So sine, cosine, tangent, that's not as much of a problem. I'm going to bring over a unit circle. And this is 5 pi over 6. So I'm going to find 5 pi over 6 on my unit circle, which is right here. And the sine, cosine, and tangent, the sine is the y value, the cosine is the x value, and the tangent, I've got this written outside, this is sine over cosine. So for sine, cosine, and tangent, this is going to be 1/2 negative square root of 3 over 2 and negative square root of 3 over 3 respectively. So let's move this unit circle over here and let's write that down. So this will be 1/2. Cosine is negative square root of 3 over 2. And the tangent is negative square root of 3 over 3. The cosecant, secant, and cotangent are a little bit more difficult to find. Remember that sine and cosecant are reciprocals of each other. Cosine and secant are reciprocals of each other. Tangent and cotangent are reciprocals of each other. What this means is if I've got the sine of this 5 pi over 6 is 1/2, then for cosecant, I'm just going to flip this upside down. 1/2, flip that upside down, that's 2 over 1, which of course is the same as 2. So the cosecant here is 2. But for the cosine, this is negative square root of 3 over 2. If I flip that upside down, okay, let's do that over here. If I've got negative 2 over the square root of 3, while that is the secant, I don't like that answer because I've got the square root of 3 in the denominator. So what I'm going to do is I'm going to rationalize the denominator. I'm going to multiply the top and the bottom by this square root of 3. This will be negative 2 square root of 3 over the square root of 3 times square root of 3. In other words, the square root of 3 squared. Square root and squared, okay? Those undo each other, leaving just a 3. So I've got negative 2 square root of 3 over 3. Okay, now, cotangent, same thing here. I'm going to take negative square root of 3 over 3, and I'm going to flip that upside down because this is going to be the reciprocal. So negative 3 over the square root of 3. Same thing here. Let's rationalize the denominator. This will be negative 3 square root of 3 over 3. And I can actually divide out these 3's, leaving negative square root of 3. Okay, what about 14? T equals pi over 2. Okay, pi over 2 is right here. So negative pi over 2, this is the same as 3 pi over 2. I want to find the sine, cosine, and tangent first. The sine, again, is the y value, the cosine is the x value, and the tangent is sine over cosine. I've written this on the outside here. So the sine is negative 1. The cosine is 0, and the tangent is undefined because if I do sine over cosine, it'd be negative 1 over 0, but I can't divide by 0, so that's undefined. So let's write that down. Sine here is negative 1. Cosine is 0. and tangent is undefined. For cosecant, secant, and cotangent, I want to find the reciprocals of these. Well, the sign is -1. If I think of this as -1 over 1, if I flip this upside down, it's still -1 over 1. So the cosecant is -1 as well. For cosine, think of this as 0 over 1. Really, it could be any number. It could be 0 over a million, because 0 divided by anything is going to be 0. But if I take the reciprocal of this, okay, flip this upside down, that'd be 1 over 0 or a million over 0, depending on what number you want to use there. Doesn't really matter because I'm going to be dividing by 0. This is not possible and therefore undefined. Cotangent. This is undefined. This is because this is 1 over 0. Or again, it could be any number over 0 because any number over 0 can't divide by 0, right? Now let's flip this upside down. If I take the reciprocal of this, it'd be 0 over 1 or 0 over a million. Doesn't matter because 0 divided by anything, as long as it's not 0, is 0. Therefore, the cotangent here is 0. All right, 15 and 16. For 15 and 16, we're going to use a calculator to evaluate the trigonometric expression. So for 15, I've got sine of 4 pi over 9. Now, when I do this, remember to be in the right mode here. So on my calculator, I see that I'm in radians. Okay, assume that this is radians unless you see a degree mark. So sine of 4 pi over 9. This is 0.9848. While I'm at it, let's do this one. The cotangent of 7 pi over 8. Now, you'll notice that I've only got sine, cosine, and tangent here on my calculator. And if I hit the second key, this only gives me sine inverse or arcsine, cosine inverse, and tangent inverse. So there's got to be something else I can do. Well, recognizing that tangent and cotangent, as we talked about in the last two problems, these are reciprocals of each other. So rather than doing the cotangent of 7 pi over 8, which I can't do in my calculator, what I can do is say cotangent is the same as 1 over the tangent. So if I do 1 over the tangent of 7 pi over 8, this is negative 2.414. That is the same as the cotangent of 7 pi over 8. Okay, these other two are in degrees, so let's change our mode. I'm going to hit mode, go down to radian degree, enter here, and you'll see now the degree is flashing and it says degree up at the top. Let's clear this menu. Tangent of 118. Now my calculator recognizes that I'm in degrees, and this is negative 1.8807. And secant. As we discussed, secant is the reciprocal of cosine. So while I can't do secant of 24 degrees in my calculator, I can do 1 over the cosine of 24 degrees. And this is 1.0946. All right, lastly, find the exact value of each expression if possible, without the use of a calculator. Okay, so let's bring up a unit circle. And I want to find the arc sine of negative square root of 3 over 2. So what we learned in the section that we did this, the arc sine and the arc tangent use the right half of the circle, and the arc cosine uses the top half of the circle. That's due to the domain restrictions that we have. And what we're going to do is, instead of me saying find, the sine of some radian measure, and I give you the radian measure and you tell me what that is, this is going to be the opposite. You're going to be told negative square root of 3 over 2. Find where the sine is negative square root of 3 over 2. So on the right half, that's right here. Okay, the sine of this point is negative square root of 3 over 2. And then you're going to say what the radian measure of that is. That is 5 pi over 3. Wait. My domain restrictions say if I'm in this quadrant for sine and tangent, arcsine and arctangent, I've got to adjust to negatives accordingly. So this 5 pi over 3 is the same as negative pi over 3. Easy way to remember this is pi over 3 is up here. If I flip this over the x-axis, I'd get down here, and 5 pi over 3 is the same as negative pi over 3. So arc sine of negative square root of 3 over 2 is negative pi over 3. Okay, arc tangent. Now I want to know, on the right half, where is the tangent 1? Okay, that's right here. The radian measure is pi over 4. So the arc tangent of 1 is pi over 4. Two more. The arc tangent of negative square root of 3. That's right here. The radian measure is negative pi over 3. And lastly, arc cosine of square root of 2 over 2. So arc cosine is going to use the top half. On the top half, where is the cosine square root of 2 over 2? Okay, right here. So that is pi over 4. And that also is the end of our final review. So study up. Our final is coming up. Hopefully this helped you out.